Hey everybody, I'm Aaron with Roost Marine, and we're talking today about tiller torque. Tiller torque is caused by the propeller spinning through the water and grabbing on one side more than the other. Because it's a surface drive mud motor, you only have half of the prop or so in the water, which means that the bottom half of the prop is grabbing water, the top half of the prop is grabbing air. And of course, there's not much grip in air, but there's a lot of grip in water. And so what that means is as that propeller spins, the tail of the motor wants to come around like that. And what that translates to you as the user is that tiller handle pushes into you. But lucky for us, the manufacturers have come up with a way to adjust tiller torque so that you can have a torque-free driving experience. This is a skeg. It's at the bottom. It serves really two main purposes. It's to protect the propeller from direct impacts or hard impacts to logs and rocks and stumps, things like that. But it also acts as a rudder so that as you turn the motor, you've got a nice big broad surface down in the water so that you can steer your boat. But if it was straight, that would not be enough to give you full control over the motor. You'd have horrendous tiller torque. So what the manufacturers do is they take the last portion of the skeg and they bend it that direction. And what that does is that takes the water as it's moving down here and it causes the motor to push back the other direction. So the way that you adjust this is you just bend it more or less. Now from the factory, the mud motor companies try to get it as close as they can, but there's a lot of factors that determine how much tiller torque you're going to get. And the reality is most of those factors the manufacturers don't have any control over. So they get it as close as they can, but if you read in your manual, it'll say adjust it. So that's what we're going to talk about next. Because of all the factors that impact tiller torque, whenever you're going out to do your run to adjust your skeg to balance out the tiller torque, you want to be really careful to make sure that you're running your boat exactly how you run it whenever you go fishing or hunting or just playing around, because simple things like having just one person versus four people in the boat can definitely impact tiller torque. If you are running a worn out prop, don't set your tiller torque based on a worn out prop. Wait till you have a new prop, adjust it for the new prop, because otherwise you're going to adjust it for that worn prop, you're going to put a new prop on there, and you're going to go, oh my gosh, the tiller torque is horrible. Well, no, the tiller torque's not horrible, it's just that you adjusted your skeg to a prop that is basically ruined. So make sure you have a good prop on there, and depending upon the design of the prop, some of them don't have to be used very long before they'll start to degrade in performance and degrade in tiller torque as well. And I guess I should say by degrade, I mean they'll have less tiller torque just because the geometry is wearing off. So whenever you go out to set up your tiller torque, try to get the exact same weight in the exact same position. So if you're somebody who likes to run just you and your buddy or you and your dog, go out like that, have everybody sit in the normal positions, put all your gear in the same positions, and then set your tiller torque. If you're somebody who wants to run heavy loaded, get all your buddies together, throw all your gear in your boat, and go run like that and adjust your tiller torque like that. The reason I say that is it will significantly impact how much tiller torque you have. So like in this particular example on my boat, I like to run it light. I usually will run 2 people in the boat max. I run a couple dozen decoys and a lot of light gear. I like to hunt really, really shallow water, so keeping the boat light is extremely important to me. Now, even though I keep it light, that doesn't mean I can't take a lot of people. I've had up to 4 people in my little boat. Now it does it gets on plane and it goes up to speed. It's a little slower than it is obviously than with 1 or 2 people in it, but the biggest change is I get a lot more tiller torque when I have a lot of weight in the boat. And so in my particular case, I like to set it up so that it runs really, really nice with 1 to 2 people in the boat. But if I want to push more, I go, you know what? I don't do that often, so I'm okay with battling a little bit of extra tiller torque that I wouldn't normally have to battle. So that's how I set mine up. Now, some of you guys might be the total opposite of that the majority of the time you're hunting with 3 or 4 buddies, and so, you know, it's rare that you're out there just by yourself with a couple dozen decoys. In that particular instance, you would want to make sure you set the skeg to balance tiller torque with that full load, because otherwise you're going to spend your whole season battling tiller torque because you've got a lot of weight in your boat. So those are just some things to think about. Don't target any one thing and blame it for that, but just get your setup how you're going to run it and then bend the skeg, and you'll end up with a really nice running boat. It allows you a lot more versatility in props. You know, if you want to change props or you're looking to do something different, it gives you the ability to do that. Now we're going to talk about adjusting the skeg to get rid of that tiller torque. When most people think about tiller torque, what they're thinking about is that motor or that tiller handle pushing into you while you're driving, because that's most commonly what you're going to experience. And what that means is there's not enough bend in the bent portion of the skeg. And so what's happening is, as that propeller is rotating through the water, it's pulling harder this direction because, you know, it spins and it grabs, compared to how much the water is getting pushed off of that bend. So it tends to drive like that. So what you need to do is bend this more so that it pushes harder back the other direction. And all you're doing is you're just trying to balance those forces. So if you're driving along and it's still pushing into you, bend this more, bend it further. And just keep doing that until you're not having to push against that tiller handle so much. And if, in some cases, it can actually go the other way. If you're going from, say, a prop that has a lot of grip to a prop that doesn't have much grip, or you go from a new prop to a severely worn prop, the tiller torque is actually going to go down, and what you'll find is it'll actually go the other way, which means the tiller handle will be pulling out of your hand. You would adjust it the same way, though I wouldn't recommend adjusting your tiller torque based on a worn prop. You probably want to do it based on a new prop, or at least try to find the happy medium between a new prop and a worn prop so that you're not fighting it all season long. But in any case, if it is pulling away from you, instead of putting more bend into it, you're actually going to take some bend out. So you're going to straighten it slightly, and you're just going to keep straightening it until that motor wants to track true on its own. Now, something I want to bring up when you're evaluating tiller torque, pay attention to where you're running. If you're running in smooth, flat, clean water, you're going to be okay. If you're running in a river or a creek channel, any area that has significant flow, or even if you're driving on a windy day, you can get eddies in that water that make the motor go like this, and it can make it really, really hard to fine-tune that skeg bend. And so you can find yourself going too much, too little, too much, too little, and then you just get frustrated. You're like, I don't get it, it doesn't work. Try to find good, flat, open water that's deep enough for you to run, but doesn't have a bunch of currents, because I've run a lot of channels and a lot of rivers, and you can just be going down them and hit an eddy, and this thing will just pull one way or the other. It'll start shaking around or moving back and forth just as it goes in and out of those currents. But then as soon as you get out into flat water, open water that doesn't have those currents, it just sits there nice and true. So make sure that when you do the adjustment to get rid of tiller torque, make sure you're running in clean water that doesn't have currents, so that you can get a true read on just how straight your motor is actually tracking. The next thing I want to talk about is selecting the right prop for your boat and how to do that, but specifically in relationship to tiller torque. So like we've talked, the tiller torque is just a balance of how much the prop pulls to the left versus how much the skeg pushes back to the right. So because it's just a balancing of force, that part's adjustable. So whenever you're trying out a prop, you want to be sure that you don't accept or reject a prop just based on the tiller torque. Because if you accept a prop just because it has zero tiller torque, all that means is that prop in that condition just so happens to match up with the particular bend that your manufacturer put in your skeg. That's all it means, but it doesn't mean you're going to go fastest or push the biggest load or run the shallowest water or run the best mud flat. It means nothing to that. So you want to be really careful. Pay attention to tiller torque, because you're going to need to know that once you've decided on a prop, when you go to actually install that prop for good and then tune your motor to get rid of all the tiller torque. But ultimately, you need to focus on the performance attributes of the prop. So what do I mean by that? Well, for now, we're going to set aside tiller torque, but the things that you want to pay attention to is, how does it control the engine RPM? What kind of hole shot does it have? Is it boggy? Does it rev up to the rev limiter almost immediately? What's the acceleration like? How does it push a load? How fast is it? Will it hold my boat on plane in a turn, or does it fall off? Do I have to trim down to keep my boat on plane in a turn? Those are all things that you want to consider, because at the end of the day, you can adjust tiller torque by just bending or straightening the skeg a little bit more, but you can't adjust all of those attributes on a prop, especially not as easily as just bending your skeg. Now, A lot of people like to take an existing prop and send it to a prop shop, their favorite prop shop, and have it custom worked to their motor. Now that certainly is a way to help mitigate prop torque or tiller torque, but the reality is, as I think any one of those prop guys would tell you, there's only so much that they can do. If you go to them and you say, hey, I want more pitch, well, more pitch comes with more tiller torque. And there's only so much that these guys can do to add more pitch without adding tiller torque. If you say, I want more cup, it's going to add more tiller torque. If you want a bigger diameter, which obviously, you know, they can only do so much to add diameter, they can, but that can come with more tiller torque. If you tell them I want a smaller diameter, that normally comes with less tiller torque. But the reality is the performance attributes that you get are going to impact the tiller torque, and there's only so much that a prop manufacturer or prop shop can do to adjust tiller torque. It can be done, but it's restricted. And so that's really why you really want to set up your prop to run the best minus tiller torque, and then adjust your skeg to counteract whatever tiller torque you end up with.